Now, this is where we come on to questions about the photoelectric effect. And questions about the photoelectric effect, especially if they're explain questions, you should seriously think about including the phrase one to one. Okay, what is one to one referring to when we're talking about the photoelectric effect? What is in the ratio one to one? Can anybody tell me? Because you
One
should.
photon for one electron.
Yes, okay. So one photon can only interact with one electron, okay? So one photon interacts with one electron. Okay, so now let's have a little look at this question. Let's do our ninja question analysis. Okay, so we are going to first of all figure out what the topic of the question is. What's the topic? I mean, it's a question set on photoelectric effect. So okay, so it's photoelectric effect. Okay. And what you should do is you should now go and get your data sheet out and you should have the photoelectric equation in front of you. And so it should be the energy of the photon is phi plus EK max. Your equation might not be energy of the photon. It might be written as HF or maybe even HC over lambda. I can't remember what is on which data sheet, but this is the photoelectric equation. Right, so now what we're going to do is we are going to identify the number of marks. Ooh, it's 2. Okay, now where is our command word? Pop it in the chat. Pop into the chat the command word. Explain. Yeah, there it is. Explain. That's our command word. Right now, the next thing to do in the ninja question reading thing is to identify all the numbers. All the numbers. So I don't think. Oh, there is a number. Look, no charge is lost. Okay, so we've got fertilizer negatively. Okay, there aren't any numbers in this question, so I'm going to highlight words which are like numbers or indicate numbers. So we've got negatively charged plate, and we've got this word loses. It's losing charge. Okay, when on a positively charged plate, okay, no charge is lost. Okay, so we've got right now. And now what we're going to do is we are going to read for meaning. And while we're reading for meaning, we're going to draw a situation. So there is the surface of the plate. And we've got, it's charged negatively. Okay. And we've got UV light coming in. So let's have UV light. Do-do, do-do, do-do. Okay. And the UV light is going to interact with an electron. And when it's negatively charged, the plate loses charge. So the UV interacts with the electron gains the energy, it gets to the surface. Remember, that's the work function. And then it carries away the electron with some kinetic energy up to a maximum. Okay, so that is the situation in the description right now. Then it says we've got to explain when the ultraviolet light is shone on a positively charged plate. Okay, so now we've got not the same situation. We've got a positively charged plate. So we're going to change this to positively charged. Right, and my photon is going to come in, and it's going to interact with my electron. My electron is going to gain energy. It's going to get to the surface, that's the work function, and then it's going to leave, is it? Well, apparently no charge is lost. What would happen to the electron if it left? What's the only difference between what happened before, where it lost charge, and what is happening now when it's not losing charge? It's attracted to the plate, yeah. So what's the difference? The charge would be lost because it's a positive plate. Electrons are negative, remember. So what will happen to the negative electron if it tries to leave the surface? I think it might just turn around and go straight back. Okay, so even if it did have enough energy to leave, it's going to get attracted straight back again. So, and that's why, okay, so we've got to explain this. Okay, remember the structure of an explain answer. Explain is key fact, consequence. Right, now, what is the difference between when it does lose charge and when it doesn't lose charge? What's the difference? Because that difference is the key fact. The plate is charged differently. Okay, in the second situation, the plate is positively charged. So when a UV photon interacts with an electron and gives it its energy, the electron cannot leave because it's attracted back to the positively charged plate. Or something like that. I mean, it's words to that effect. Can you see that you need to start off with the fact that in the second situation, the plate is positively charged? That is the key fact. The consequence of it being positively charged is that it attracts back the electrons that otherwise would have left. Okay? Can you see how that works? I hope you can.